Hi, my name's Lowell Gustafson. Thank you for attending our panel. As much as I do wish we were still being able to meet in India, this online digital format has its own advantages, and I'm glad that you can participate in this way for the fifth global conference of the International Big History Association, which is still at its heart located in Pune, Maharashtra, India, at the Symbiosis School for Liberal Arts. The topic that I want to talk about is big history first as an origin story, but then also as a coming of age one, and that it teaches a variety of values, that it has significance in a number of ways. The board members of the IBHA met for quite a while this past year talking about what values the organization represents, including cosmic and human and so on. And we'll talk about why this comes out of the big history. Now, big history itself, the science of big history, I think teaches a variety of values. Some of them are consistent with the ones that the organization wants to stand for. Some of them are different, and part of the coming of age story is making a determination as to which of these values we want to help foster, and I'll talk about that more a little bit. But let's start with the idea of an origin story, and of course this is the book. This is the title of David Christian's recent book. It's also the name of the IBHA bulletin, which has some 76 issues over the last 10 years or so. So an origin, more to the point, is key to the idea of big history, that we have a series of origins. And we have the origins, of course, of the universe with the Big Bang. We've got the origins of quarks and protons and then atoms, and then fusion in stars with heavier atoms, and chemicals of a number of different atoms. The origins of our planet Earth here, the origins of life, the origins of increasingly complex life. And then eventually the origins of Homo sapiens, of human beings, and then we have a series of origins of increasing complexity in the relationship among humans, and kinship groups and multi-kinship groups, as cities and nations and multi-city states, in national empires. We can date the development of a human or a global identity to various dates, but we've got issues now of if we discover life on other planets, will we begin interplanetary relations? What does it mean to relate to technology, to transhuman technology? We have that. And if the multiverse idea is right, is there any way we can at least imagine and have some evidence for some kind of a relationship with other universes and an so what we've got is a story of emergent complexity over a series of thresholds or transitions, steps of development from relatively more simple units to increasingly more complex set of units of relationships within units as we keep stepping up here in this process. And that all of these point to the steps which were taken from the Big Bang all the way to where we are now, and that we have a series of steps which we hold in common. We hold in common with everything in the universe, at least all baryonic, all normal matter, all of humans, all of Earth, all planets, all galaxies, all stars have their origins at the same point of the Big Bang, we think anyway. That seems to make sense. And that we are all Earthlings in many sense, those of us who live on Earth and those of us, those inanimate objects which are on Earth. We have the origin, the whole accretion of the Earth some 4.56 billion years ago, following the origin of the cosmos about 13.82 billion years ago. And then all living creatures on Earth, all Earthlings, share a common ancestor, the last universal common ancestor, Luca. We don't have a precise date for when Luca appears, when life originates, but it's somewhere around 3.8 billion years ago or so. And then we have a series of origins of increasingly complex life forms, eukaryote cells, multicellular organizations, and then starting in the Cambrian period, a real explosion of increased complexity. Eventually, this process of evolution leads to hominids and humans. Some 300,000 years ago, it looks like this took place originally in Africa. So we have all currently existing human beings have a series of common origins, and we hold an enormous amount in common with the universe. Carl Sagan liked to talk about how we are made of star stuff, and that if you want to bake an apple pie, you have to start with the cosmos. We have common origins with the universe, with the cosmos, with Earth, with life, and all humanity, and that we have this common origin story, which is a story for all of us. We are all included in this story, and this is a very important message, we think, of big history. And so the way that we talk about the cosmos and the way we understand the values of a humanistic or a human identity is connected. This is possible, of course, because of the increased energy flows. This is what Eric Chasen showed us some years ago, was that every one of these steps depends on the availability of high quality energy. Now, this is not the case, of course, for the entire system. It seems as though the second law of thermodynamics holds there is increasing disorder across the system, but within pockets we can have increased complexity because of the availability of high quality energy, in our case, of course, thanks primarily to our sun. And so we're able to get, and the big question that we've got now is, how do we solve the energy crisis to continue to provide for even greater amounts of energy in a sustainable fashion? And we haven't quite figured that out, and that could threaten all of this. Anyway, so I think this is a fairly common interpretation of big history. Now, I would like to start getting to the issue of the coming of age story in addition to this origin story. And by asking, maybe our big history story has been a little bit too restricted, a little bit too small. And it might conflict a little bit with the dominant values that we want to emphasize. We all know, of course, that our current universe, our actual universe, is much larger than what is visible to us. We can only see out to 13.82 billion years ago, and of course what we see when we get out that far is what we see then is as it was 13.82 billion years ago. We see very early forms of the galaxies that we're able to to perceive. And since then, they have gone well beyond our view. We have no idea how they have progressed or not. There's an enormous amount that the universe is expanding almost at the speed of light at its outer edges relative to us, and most of it is beyond our view now. How it has proceeded, we don't know. So instead of increasingly complex relationships, we have this expansion, the parts of the universe beyond our ability to directly detect them, much less relate to them in clear ways. Now, maybe they are, associated with the dark energy, which is associated with the expansion. But in any case, could we say that in a sense the universe is fragmenting? It's expanding. We have less and less meaningful relationship with parts of that. And the universe as a whole is increasingly disordered, and that will come back to the idea of the end of the universe, but that it's coming apart at the seams in many regards. And one of the views of the future is one of heat death, where the universe becomes absolutely cold and dark, and then that's sort of the end of all complexity. So the lessons of the cosmos, or what the science is teaching us, is complex, and there may be some irony and paradox in what it's teaching. The next part of the story, and of course the Big History Association looks for the integrated history of the cosmos, Earth, life, and humanity. The history of the cosmos is complicated. Maybe focusing on Earth is a bit of a problem as well. Even if you just go out into our own home solar system. You get out to Saturn. Saturn's quite a ways from us, no doubt, but it's not even the furthest planet from us. And when Cassini took a picture, when the famous blue dot picture was taken, you can see Earth, but it's a pixel on our screen. And this is just here from underneath the rings of Saturn. Clearly, Earth is not the big deal that it is for us, at least within our solar system. And then if you advance it, we have various ideas of what maybe the way the entire universe is structured, that there are these relationships among the galaxies which go all the way back to the relatively unequal distribution of matter shortly after that. But in any case, when we have these views, you can't even find our galaxy as a pixel. That just becomes lost in amongst all of the other galaxies here, and finding any specific part of the Milky Way is impossible. Finding the Earth is out of the question. So when you look at the cosmos, should we really go from the cosmos to Earth? That's talking about a pinprick, not even the needle in the haystack. It's not even that big. And you don't have to talk about the entire universe. Just talk about our local area of our own galaxy. And it's not just the Earth which is striking. I mean, over the last couple of decades, we've had this incredible development of evidence for exoplanets, for many other planets. We weren't sure for a while if we didn't have much evidence, but then we developed, so we know there are thousands of other planets which may be potentially habitable because they are in that sweet spot that seems to indicate they could probably sustain liquid water, and we're interested in that because we can't quite imagine life without liquid water. And so that means not only are there many other planets, but many of them are habitable, and so and this is just these are just within at most 5,000 light years of Earth, and the Milky Way itself is 100,000 light years across. So the thousands of exoplanets of which we know don't even include all of those in our own single galaxy, and we can only kind of speculate as to how many there might be across the universe, but it's huge numbers. So if we start with the cosmos, how can we just jump from there to Earth? And shouldn't big history include what it means to have all of these other planets available? In the same way with life. And you can look at it from two different perspectives. Let's just restrict it to life on Earth. I think one of the common images of life is we start with early forms of life, and then we go up to humans, and of course that's where big history takes us. We look at life on Earth, and then we look at the evolution of life, and it leads to apes gradually standing up, and then humans walking along. But it leads in a huge number of other directions, and that's why this circle of life is a little bit better. It does all start with Luca, it seems, but then it goes from there to every other possible form of life that you can find here on Earth. And so to go again from cosmos to Earth and then to living humans, as opposed to what the biologists do, and they look at all forms of life. The biologists are better historians of life very often than the definition of big history leads us to do. We have at Villanova a scholar who's a specialist on geckos. He's made his career studying geckos. And now that doesn't fit into the big history model, but maybe it should. The evolution of geckos is intellectually just as interesting and important as that of humans. So you've got that. And then, of course, you've got the great issue of life on other planets. The whole astrobiology field has demonstrated that there is good reason to think, or at least there's some reason to think, that we're going to find life on other planets. There's great excitement even now about could we find evidence at least of former life on Mars? Is that possible? Maybe on one of the moons of Jupiter? Is that possible? But there's great interest in the idea of and the real possibility of life on other planets, maybe even within our solar system. And it's just hard to imagine there's no other life in the universe. And the Drake equation tries to tell us what we need to look for to come up with a reasonable calculation for how likely it is that there is life on other planets. And so when the Big History Association talks about we want an integrated history of the cosmos and Earth, well, why Earth and not other planets? And then when it says life, it's really implying life on Earth, but we need to think about life on other planets, other life forms. I mean, certainly this is interest in Star Wars and Star Trek and all of that, but that's in popular culture. And then even if we restrict ourselves to life on Earth, to include other humans. So this is one of the issues. Maybe all of these definitions need to be considered a little bit, and to avoid this great chain of being definition that we've had, to come of age in the sense of realizing this whole process of cosmic development is not all about us, leading us to the question, well, what's the rest of this big cosmos for? What's it good for? I mean, what has the Andromeda Galaxy ever done for me? And there's that attitude of that everything leads from the Big Bang to us, may be the wrong message to send. It's a very self-centered kind of message that we need to take an active interest in things other than us. That's part of coming of age, to take an active interest in others on their own terms, and not only insofar as they're of instrumental value to myself. All right, let's look at a couple of other issues. We talked about, of course, the stages of development, the thresholds, the transitions, the emergent complexity. One thing that's important to remember, of course, is that at each one of these steps or stages of development, there is a great deal that does not become more complex, that stasis, that what is unchanging is probably more common than what does become more complex. There are still enormous clouds of hydrogen and helium going back all the way to the Big Bang that have not developed into stars. We have a lot of star nurseries coming from that, but there's a lot of clouds which have been sitting around there for nearly 14 billion years without having developed greater stages of complexity. And this is true at every stage along the way. Take the emergence of life here on Earth. We have Luca, some sort of prokaryote cell, perhaps. Well, we still have enormous numbers of prokaryote cells which have seen no reason to develop greater complexity. They haven't even become eukaryote cells, much less multicellular organisms. And then that could be said about each type of life form that develops. We have hagfish early, they haven't developed. They're still around with us. We've got nidarians, jellyfish. They've been around for hundreds of millions of years. They're still more or less the way they've been. There's a lot of unemergent complexity that does not become more complex. And the others, we have moving from what is more complex to what is more simple, rather than just from simple to complex. Things break down, things deteriorate, things dissipate. This is common at the individual level, it's common at all kinds of level, and maybe it's going to be common even in the long term at the universal level, in the sense of that we're expanding, dark energy is pulling the universe apart, if that's what the right language for it, and that eventually the whole thing comes apart at the seams and there's no complexity at all. And maybe part of coming of age is coming to terms with that reality. It's much more fun to talk about origins, the birth of this and that and the other thing. It's not as much fun to talk about the endings of each one of those things. That there is there's a pattern here, which of life, of birth, and of endings of death. Now, what should we learn from this? Now, a lot of people look at the development of life and nature, and one of the lessons of big history is to see how rooted we are in nature, that if whatever human nature means, it is very much rooted in a 14 billion year natural evolution, and that we exist only because of that. And a takeaway message of this is, well, we better actually perceive ourselves as part of nature and take some responsibility for our effect on nature. We are that part of the universe which is aware that we have this effect in the Anthropocene, and it's not been a terribly positive one in many regards, and so that we need to become environmentalists as a result of that. This is a lesson that many take from big history, and we look at the effects of what we've done to the Earth, changing the carbon levels of the atmosphere, leading to climate change and to the increase of heat. And we see that here in the United States, with increased heat, droughts, and a good share of the country, increased rainfalls in other parts of the countries. We've seen that in other parts of the world, where we increasingly are having real enormous hotspots becoming virtually insufferable for humans. And what is this going to do to our globalization and human identity? We're already in the midst of the greatest migration since the end of the Second World War, which is part of the causes of populism and ethno-nationalism, that as we have forced migration due to increased climate change, we've seen this here in the United States, the increased intensity of hurricanes in Honduras and Central America have been one of the reasons for the increased migration from those areas into the United States, and this has been a political conundrum for the United States as to how to deal with that. But will that get even worse? Will this lead to an unraveling of whatever small degree of globalization and humanity that we have? We are in the midst of what Elizabeth Kolbert has called the Sixth Extinction. Of course, since the Cambrian period, there's been 5 naturally caused major extinction periods where we have a great decrease in the existence of complex life, and it's recovered fairly well. In each time, but it took a long time. Now we seem to be the principal cause for the 6th extinction of many, many species, and we hope that we don't get caught up to that degree, although there are some who insist that we've already passed the tipping point. And now the lesson to learn from what we've done to ourselves is to accept it, and we need to learn how to die in the Anthropocene. We're doomed, the wise person finally agrees to go into hospice to come to terms, and not just with personal death, but even with species death. And at some point, that's going to happen. We've only been around 300,000 years. You compare that to the Earth history and the cosmic history, and it's a blink of an eye. Species don't last forever. 99% of the species that have ever existed are extinct now. There's no good reason to think that Homo sapiens are going to survive for the next couple of billion years until the sun becomes too hot to sustain life on Earth. Somehow we assume that's going to be the case often, and one wonders why when we've been here such a short time. But whether or not we do, of course, one of the best sellers here in the last number of months has been Katie Mack's astronomical book on the end of everything. It's a wonderful book, and different evidence-based, reasoned theories of what we can expect over the long term. And essentially, in one way or the other, the universe is going to end. And so it's not just an origin story, it's an ending story. And all of that is taking place. And this idea of heat death, the idea of expansion, of fragmentation, of coming apart, is just part of the natural story as well. I mean, we've seen the same thing even in big history. We don't just have one organization which represents everything in big history. We have the International Big History Association, but we have the Indian Big History Association, the Asian Big History Association, the African Big History Association, the European Big History Network. We have various big history centers at different universities. We've got the Big History Project. There's all kinds of different organizational ways of talking about that, and identities which go along with that. So if we have big history as a common origin story for all of us, those who are telling the story are still comfortable, or perhaps they prefer associating with various national or regional associations and even different interpretations of all of this. It's not just a single story which we can all find ourselves a part of. There's greater complexity of that. So what's the connection between that and being cosmic and human? And part of this is there is a great range of messages which comes out of the big history story. Many of them are differentiated meanings, maybe some meanings in conflict. But part of coming of age is making choices. It's often been said, for example, that we humans are that part of the universe which is able to reflect on itself. We come out of a universal process, the hydrogen and the carbon that makes us up, the amino acids and proteins that make us up, the various bioplane of body plans that make us up, the fact that we have 5 digits on our hands and toes, feet. All of this shows how rooted we are in nature, and then we, as Fred Spear emphasized in his book on Big History and the Future of Humanity, our brain is the most complex matter in the universe of which we are aware, right? 100 billion neurons with a trillion synapses, incredible ability to think. And so we come out of a universe story and we are able to reflect on itself, but maybe there's even more than that. What we see in the universe is this series of steps, this emergent complexity. It's a story of, we could almost call it creativity. There was nothing and then there was everything in the Big Bang. There were no atoms and then there were. There were no stars and galaxies and then there were. There were no terrestrial planets and then there were. There was no life and then there was. We've just got this series of creations, of origins. This is part of the origin story, of course. And that we get to this idea that when we finally get to humans, and we are self-conscious, and we develop these incredibly complex brains, we are able to be explicitly self-conscious and to self-consciously reflect on our place within the universe. And like the universe, we can be explicit in choosing how to create what little bits of it we can in the future. So for those who are seriously considering how should we try to manage the Anthropocene, this is a coming of age story. This is saying we want to make choices as to how we're going to develop this. We want to be as creative as the universe has been in the past. That much of the universe is in stasis, but there have been these punctuated periods of change, and that we can do that. So nature is not determinative. Nature is suggestive of that we look at the conditions as they are, and that we can now make explicit choices to nurture values which will improve, which will develop, which will lead to greater complexity in relationships among that. And this is ultimately the coming of age story, that we are not doomed, we are not destined for anything in particular. Maybe in the long run, the second law of thermodynamics is going to win, but as long as we still have sources of high quality energy, we can manage them. At least there's a possibility that we can manage them, so that we are that part of the universe which has come of age, realizes if we don't do that, what will happen, and then make effective choices on how to continue a very sustainable origin story. Thank you.